Hello, everybody. My name is Daniel Krakowiak. I'll be talking about the tools we've been developing in our company for the last several years. We call them Errant Worlds. They are divided into three parts. One is for landscape, one is for procedural generation and placement, and one is for paths or everything which is spline-based. A bit of background on who we are. We started professional game dev in 2014, but long before that we've been really hardcore about computer graphics, physics simulations, writing game engines. And since 2014 we've been gathering experience from companies like Techland, CreepyJar, Pixeland/Sumo Digital, and Google. We started this company and development on these tools in 2018. And we were also developing a game alongside. And as I said, it was for landscape placement and paths. And the map for our game, which was an open world racing, was 8 by 8 kilometers. And we knew that we can't be doing the map the way some of the big players do it. So using an army of artists placing objects on the map, we had to be smarter if we ever hope to catch them up. So we watched a presentation from Ubisoft on how they worked with Houdini and thought that we will simply replicate what they did. It has to be a good idea because it worked for them. So we started with combining Unreal, combining Houdini and World Machine. We thought that World Machine is exactly what we need. We don't need to do the landscape in Houdini. And we've invested almost a year into that solution. We're really excited about it, and we really thought it will work for us. You can see the screenshot of our generation in Houdini up top. However, we discovered that there are serious problems with this workflow, at least for a smaller studio like us. The main one is slow iteration. Whenever you are in Unreal, you want to change something, you have to go back to Houdini or World Machine, regenerate, and then re-import. And also the integration between Houdini and Unreal wasn't the best at the time. That was taking ages. Iteration was really slow. Also, as you can see the images there, we were generating lots of images that we had to import, export, store in the source control. That was just very slow. And it was convenient to start. You had all the nice tools to start, but the moment you needed to make edits, it was very tricky. Also, the moment you left Unreal, you were losing a big part of the context. You were losing the sense of scale. You didn't have your textures, game objects. So sometimes you couldn't even find the spot that you were trying to edit. Also, as just the raw performance wasn't really what we hoped for in Houdini, we started rewriting nodes. We were writing lots of our own nodes and in Python, OpenCL. We were optimizing as much as we can. But over time, we realized that we are doing programming just in Houdini in small windows. So we didn't have source control, we didn't have IDE, and it wasn't really that convenient. And we weren't benefiting that much from Houdini because we weren't using the built-in nodes anymore, almost none. And also, because it was Houdini, it was highly technical, so we couldn't expect artists to just go to Houdini and change things. It was maybe 1 or 2 people in the team who could do it, which is a big problem. We also tested built-in tools in Unreal. One of them is procedural foliage. It's a tool that hasn't been developed much in the recent years. Quickly discovered that it's very limited in control. You have a number of properties that you can change, but you exhaust your options within 1 or 2 days, and you simply can't achieve what you wanted. You don't have enough artistic control. Also, it's not programmable. You can't do custom logic there. So yeah, you would need to rewrite it pretty much to get more options. And also, it's only spawning things offline, meaning in the editor. So this restricts you. You can't spawn dense things like grass, because if you were trying to spawn it offline and store it in the map file would have like 5 gigabytes of size. But there is landscape grass, so we thought that this is not a problem. Landscape grass is spawning at runtime when the camera in the game is moving. The landscape grass is spawning things based on the landscape material. And it is programmable because you have the landscape material, you can edit it. However, at least in our project, the compilation was very, very slow. We didn't have like a huge landscape at the time. The material was quite complex, but we were spending like 15 minutes to compile this material for like various tiles, and that was way too slow to work conveniently. And also because it was one material, we couldn't like multiple people couldn't modify it at the same time, which is again a big problem. We also evaluated a bunch of other tools that you can get online on Marketplace and so on. But we discovered that they are mostly focused on landscape. They are very often runtime, meaning that even the landscape sometimes generates in runtime. They don't have programmability, or it's like very messy. So like a huge material where you keep fiddling with it, it's not good at all. And also these tools had a problem that they were creating their own ecosystem within Unreal. So you would need to lock yourself with that ecosystem, also losing some functions of Unreal, which we didn't like. They also weren't made for teams. Like I said, sometimes only one person could be changing something. You could just see that there were like mostly hobbyists doing these tools. And also they didn't have good UI, so you had like long list of properties and so on. No debugging most of the time, which is also important. And these tools were often written in blueprints, which some people see as an advantage because less advanced users can modify it. But for us, that was a drawback. It was always way slower than it could be because it was written in blueprints. And that was the case for the tools for paths that we were using. When we were trying to set up a highway on the map, editing this highway was just very, very slow. And also we were lacking control in terms of paths. So with these properties, you could say that you want to have lampposts every 50 meters, and maybe move these lampposts a bit, but that was it. You didn't really feel much control. So we thought that after that year, we thought that it isn't working for us. We have to do it again, and we have to do it in Unreal, fully in Unreal. We don't want to ever leave Unreal while working on the map. So that was the main goal of the new tool. The second one was to have quick iteration, both in terms of raw performance and in terms of overall iteration. So whatever is slowing you down is affecting iteration speed. We also wanted to maintain the balance between automation and control. So just because we are using procedural generation doesn't mean we want to give up any control. We want to always have the final say of what is spawned where. We wanted it to be programmable as well, so that you could have any custom logic you come up with and not be restricted to a list of properties. From our experience, doesn't matter how many functions you have in properties, if it's a fixed number, someone will always ask for more, and it becomes a mess over time. And we, of course, wanted it to be done with teams in mind, so that multiple people can work in parallel. And I will quickly go through what these tools are before I go into details, because I will be discussing these points in details, how we achieved them. So these are the three tools, one for landscape, one for biomes, and one for paths. Errant Landscape is a tool which is brush-based, so you are moving brushes, which may be whole mountains, it may be like tiny brushes, doesn't matter, and it's non-destructive, so once you place a mountain, a year later you can still shift it with other brushes. It's all built on Unreal Landscape, so we are not revolutionizing anything here, and it's optimized for large maps. So you have something like that in Unreal, like with blueprint brushes. It's just not optimized for large maps at all. If you put many brushes or your map is larger, it slows down to a halt. So, and in here, some of our customers are like placing thousands of these brushes on large maps, and it's working well. And here's an example of how this workflow looks. So let's say you create these mountains in a world machine, and then you have a library of such brushes, and you are just combining, scaling up and down, and rotating them, and very quickly you can achieve realistic results. And what is interesting here is that the erosion is already baked in these brushes. So when you scale them up and down, you could think that maybe there will be like some disparity between them, or you could see some edges. But from our experience, it's just impossible. You could never tell that something is off here. Biomes is for procedural spawning of pretty much anything: meshes, decals, grass, FXs, blueprints, lights, sounds, whatever you want. And the core idea is that you define the biome once, and then you can very quickly paint it over any area you want. It's a matter of seconds. So in here we're painting like a forest biome. And it's there. So it spawns trees, it spawns mushrooms, bushes, grass. Every little detail is already saved in that biome. So you don't have to redo this work. You do it once. And we split the data that we have into biomes, which are pretty big, like the size of a country or a city, or it can be smaller, of course. Sub-biomes, which you can see here, that the forest part is a sub-biome, and species, which are separate, let's say, plants, like grass, trees, mushrooms, and so on. Here is the same thing from the ground level. And paths, paths is for everything spline-based. So it could be roads, it could be railways, it could be rivers. And the key thing about this is that first, it affects the environment. So it can write biomes, it can remove biomes. Like in here, we set up a road through the forest, and the forest clears along the path. But also the road adapts to the environment, so that, let's say, you may have a barrier which is placed only on the left turns, or maybe when there is a cliff next by, when the road passes through a forest, you may spawn leaves there. You can do pretty much anything. You define these rules. And now I will go into details of how we achieved certain goals. So programmability first for biomes. At first, we thought of creating our own editor for nodes and graphs, but quickly realized that a material editor is actually the best choice, because people are familiar with it, and you have lots of functions in there waiting to be used. So we have 3 types of materials which control how, let's say, a species or sub-biome spawn. One material is for growth, so like density, how much of a given species spawns in a given place. One is for scale, so you may do like fluent or rapid changes in scale. And one is for asset selection. So if you have, let's say, a small bush and a bigger trees, you may pick one of them based on the environment. And in here, I selected the place where you can just enter and modify this material. And you can pass a number of inputs to this material. Of course, you can sample a regular texture like in any material, so it could be a splat map, for example, but you can also access landscape weight maps, so spawn based on a given weight map. You can access hand-painted masks, which is our own system for painting masks, and you can also do interspecies dependencies. So let's say you want mushrooms to grow only where the grass is. It's a one connection and it's done. And also, this is how it looks. So quite often it's simple, and you combine like procedural noise there. Yeah, you can put procedural stuff in there, of course, like noise functions, and it's just very easy. Like sample this, multiply by that, and that's the output. And also. What the direction in which we want to go is to have all the metadata, or like so-called splat maps, accessible in Unreal. So things like slope, precipitation, sun exposure, so that you don't ever have to go to Houdini or Word Machine to regenerate this data. It will be regenerating in real time. It's already done for some metadata, but we want to have like a complete list this year, which would be a big improvement in iteration time. Here's an example of how you can use a mask. So it's up to you what the mask means, because you sample this mask in your material and you decide what it does. And in here, I created a mask which replaces normal trees with all the trees, or like dead trees. You can use a mask to remove the foliage entirely, of course. You can use the mask to maybe remove only large species, like when you have a bridge and some foliage under the bridge, you may leave the small ones. It's really up to you what to do with it. And of course, because it's a material, you can use material functions and reuse parts of the code. Here's an example of spawning based on landscape weight map. So we are spawning grass where the grass weight map is. Here is an example of interspecies dependencies. So leaves are a separate species and they spawn under the trees, where the trees are. And here is the visualization of the metadata. So the red parts are the slope, and you may pick to spawn something based on slope and noise and weight maps, and all together mix it together. So that's for biomes. For paths, we also wanted to have programmability. At first, we had meshes, and we said this mesh should spawn if a function in that blueprint returned true. So we had all of that logic in one function in a blueprint, or it was a function library where you could maybe use these functions together and mix them. But it was very hard to use. Even I was getting lost when trying to use it. And also when something didn't spawn, it was very hard to tell why, because it wasn't there. So you didn't have a way to debug it. It just wasn't existing. So we decided to split the problem in two parts. And the first part is now what we call labels. We call them labels because it's like labeling an image in AI, where you mark parts of the image and say what they are. So these labels may say that this is a sharp turn, this is a downslope, this is a dangerous area, this is a forest area. And you can program these labels very easily. You can say what they do. And you have like a debug view like you see here. You can check which ones you want to see. So this is very helpful. And when you know that the label is in the right place, then if the mesh isn't spawning, then it's probably a bug, because it should be there. And we use these labels to spawn not only specific meshes, like a barrier, but even picking the whole segment of the road. So it could be a tunnel, or it could be a normal road, or any other kind of road. And here is an example of us picking a label. So we have a mesh in the blueprint, and we say it should spawn only when a certain label is present. It's also very easy for artists to use, which is very important. And here's an example. We have a label which marks like a sharp left turn, and we spawn a barrier only when that label is present. And we also, this is the example of how a label logic looks. So as you can see, it's super simple, and you always have the position and the direction of the spline point, so you can do your own logic. You can check if that point is within a volume. You may do a volume check whether there's empty space next to it, anything really. And we also make it easy to do nested labels. So when you have a sharp turn, and let's say a downslope, you can create a single label which encompasses the two. This is this get node here. The second goal was to maintain balance between automation and control. And I will start with biomes. So the important bit we achieved was that you can have a varying level of automation. Just using these tools doesn't mean we have to do everything procedurally and then lose control. We start with procedural. So let's say we can use a simple noise to decide where each sub-biome is, as you can see in the image. And we have forests only in certain parts. But we can apply control at a lower level through masks and sampling these masks. Here is an example of, let's say we're adding 3 or 4 masks. One is controlling, let's say, the density. Another may be controlling whether we want this species or sub-biome here. It's up to us, really, what to do with this. Yeah, and as I said, we have 3 types of masks, so we can control various aspects of that generation. When it comes to paths, as I said, we really didn't like the way other tools were controlling placement, like every 50 meters place a lamppost. So we tried with setting blueprints, what we call templates, where you have a cross section of the road. It may be very short or long, it doesn't matter. And we have a bunch of such templates. We scan them for components and we spawn based on that. And what is also interesting is that we can have a number of these templates. So like in a layered fashion, where you have the base mesh in one blueprint, you have decals in another, you have barriers in another, and lampposts in yet another. You can mix and match them for different roads so that you don't have too much content in a single blueprint. Yeah, this is how we set these layers, the different blueprints. Here is one with just decals. And here is an example of how such addition looks. So we are replacing a barrier with some rocks. We regenerate the road, and the rocks are spawned. Then we apply some, let's say, random offset, and it generates. It's fine. So artists feel at home with such tools. They simply do what it feels the same as doing it on the map, which is really important. Here's another example. We are just moving decals, creating like some interesting pattern, and we regenerate the road. So achieving something like that with tools we tested would be quite difficult. You would be fiddling with rotations. I'm not even sure if we could achieve that. Another thing is we have proceduralness, but we still want control. So when we have a label, we can still manually extend it. This means I want this behavior to be farther, like a turn. Let's say the turn is farther. Or I can remove that label manually. And it's also very important to communicate with the user that the procedural label is there, but you removed it. And you can, of course, reset it back to procedural if you want. And as you keep regenerating the road, the system remembers your manual addition. Another goal was to have quick iteration, both in terms of performance and the workflow. And with biomes, we started with Houdini. After a year, we decided to move to Unreal, and we implemented generation on CPU. And it was already about 10 times faster than Houdini, but the generation of like a tile that you're working on, or like a set of tiles, was taking like 40 seconds. And we thought that this is still too long. It's still too tempting to go to YouTube or just stop working altogether. So we rewrote it again to run it on the GPU in shaders and multi-threading and everything we could squeeze. So then we got down to like seconds, maybe 5 seconds per what like a typical working space, which was pretty good. But we did some mistakes along the way. At first we implemented what we called viability. Viability can be interpreted as willingness of a certain instance to be there. And these instances had radius, and only the one which wanted to stay there the most was supposed to stay there. It was supposed to remove other like competitors within that radius. So let's say that that's the viability visualized as the color. And then you have to compare like many points with many other points to deduce which ones should stay there. And this is not something that you can do in a single pass in shader. You need multiple passes. This is overly complicated. We realized that we don't have really a useful use case for that in the real scene. And so we moved to a simpler solution, which we simply call spacing. And when you set a spacing to, let's say, 10 meters, that means that the initial set of points, the distribution of points, of spawn points, each point will be 10 meters apart from another, pretty much. So the spacing is guaranteed. You don't need to keep checking that. Because we were checking viability within a single species even. We were thinking it's like a unified approach, but that was a bad idea. And so spacing solved it for us within a single species. And when you do multiple species, and because they have priorities, so like one species is affecting another, removing instances of another, that's simpler because we already know where that more important species is already. And if within a single species, at the same time you're removing points and checking if they are still there, so this is much harder. And also what's important is that we have no runtime cost for the generation. It's all done offline in editor, and it spawns in the map. You save the map, and it's the same as if you were placing these objects by hand. So you can go crazy with the logic, and we sometimes go crazy with it. It's also important to generate only what has changed. So when you have dependencies between species, you only generate the ones that your change affected. This is also important. And partial regeneration. So we do have world partition in Unreal, so you could be loading just a small part of the world and work on that part, but this is not very convenient. It's better to load a big part, let's say 2 by 2 kilometers, and still work on a smaller part with your species. Maybe you're tweaking some bushes and you just want to test them here, and a few minutes later you want to test them on a hill. So you can do it. You select a few tiles, and we are regenerating only these tiles. What was important for overall iteration was also to have runtime and offline generation in one system. Because first off, you can move species between these modes, like offline and runtime. Maybe you change the density, now you want it to spawn offline. Maybe you care about collision more. And also, people don't have to learn 2 different systems and so on. And we removed the long compilation time for the landscape material this way. And this is, you can see the runtime generation working here. The flowers and grass are generating. And we set the distance, like draw distance, to a short one just to show how it works, because when they spawn depends on the draw distance pretty much, plus some margin. And what is really amazing about this workflow is that you are not afraid of vision changes or art changes. You're not afraid of the changes at all in general, because you can start with very simple biomes, like we use these meshes to mark certain regions of the map. Everyone knows that there is a forest there, but it's not heavy. We can keep modifying the map. We are not afraid of doing changes because we can always regenerate stuff, and we never redo the work. So it's not like you made this beautiful forest and then they want it moved elsewhere, or maybe they want a different forest. You made the forest and you can place it anywhere you like, and you're not wasting time. And if you decide to change it, you change the biome, you regenerate the world, it's done. And I think removing that fear and that wasted work is like crucial really for overall savings in game development. And also, of course, you're working with context now. You have all your game objects, textures. Very precisely, you can be doing modifications to the map. When it comes to landscape, the first thing which affects iteration was for it to be non-destructive, of course. In terms of raw performance, it was important to only update the area which is affected by the brush, because the built-in brushes have a bottleneck. So the larger the terrain, the longer it takes. With us, it's not the case. You only pay for a number of brushes which are put on top of each other, but you have to put quite a lot of them to make it slow down. And also, right now, or maybe a week ago, we've been still using blueprint brush, a single blueprint brush, to write our results into the landscape edit layers, or height map. And this was slow because there was still a single bottleneck. We were still affected by one bottleneck of that blueprint brush system. So we recently moved to just writing directly to the edit layer. And this way, we don't have any bottlenecks like that. We made these brushes components. This is very useful because you can put them in a blueprint, and you have a mountain range, for example, or you have a house with a number of like hills around it, and you can move it and place it. And we also added quite a few like UI things with like the markers you see here. Because when you have hundreds of these brushes, you may get lost. So we added things like sprites or meshes, which you can easily click to select a brush. And the way we want to go forward with this is to do more of like Gaia and World Machine in Unreal. So that you could maybe make your own brushes within Unreal without going to World Machine. Or maybe if you have a huge landscape, you may do it like more crudely and then apply the erosion at the end. But this is tricky because when you apply erosion, everything shifts down, so you need to shift the game objects down as well. So we really think it's probably more useful to just create brushes before with erosion. For paths, what affects iteration is of course the fact that you define them once and then you keep reusing them. The barriers, all the objects spawn automatically. Also the fact that they are adaptable. So once you spend time creating such logic, it then works well in different environments. The road may turn into a bridge, may turn into a tunnel, adding all these objects along the way. You are reusing templates, reusing labels, also just cutting through the biomes or adding biomes, let's say trees along the road, is also very helpful. And we're also creating paths where you are only painting on like landscape weight maps and spawning decals there. And of course you need things like cutting, merging, intersections. I won't go into details here because I don't think we solved intersections fully yet, but it's very needed for quick iteration. We also have something like preview mode, because once you have lots of meshes in the road, it of course takes a moment to generate, and when you just want to quickly adjust the path, you only care about the base mesh really. So we have a mode where you can simplify the generation. We also, very often with any kind of path, you need some sort of spline to tell AI that the path is there. So we solved it in a way that you place a spline component in the template, and we then spawn this component, but we merge them together into a single long spline, as you can see here. We also discovered that using runtime virtual texturing is great for roads, because roads don't have a big surface, and they are along a camera, like extending along a camera, which is really useful for like loading the textures and streaming them in. And you very often have lots of decals in roads. So with runtime virtual texturing, you render all these decals into the virtual texture, and then you're only rendering then you're only using this texture to render the actual road, which is a huge saving. However, there is one issue. We are spawning spline meshes often for roads and static meshes as well. And spline meshes don't have support for instancing in Unreal, which is a big problem. And so instancing is simply a way to draw, let's say, 100 objects with a single draw call. And you certainly don't want to be doing thousands of draw calls for a big road. So what we still need to do is to implement instancing for spline meshes and maybe make a pull request to Epic to integrate it with the engine, or maybe deliver it ourselves. And then I think the last goal is efficient team cooperation. And for landscape, the important bit is that all the brushes are independent from the landscape actor. So if you are modifying the brush, you don't check out the landscape actor. If you were, you would be the only person being able to do any changes. So they are independent. So multiple people may be editing different brushes at the same time, and they are then only checking out the tiles of the landscape that they are changing. But despite that, we still need priorities for these brushes, so that some brushes override others, and you need to be able to manage these priorities. Unfortunately, I didn't catch a screenshot here, but we have a panel where you can easily modify the order and group these brushes together. With biomes, thanks to the fact that we split all the assets into sub-biomes and species, multiple people maybe are editing different aspects of the generation, different species and sub-biomes at the same time. They may be even editing different aspects of the same species, like scale and growth, because they are separate masks. And also, we think it's very simple to create these materials, but maybe it's a bit too complex for some people, or maybe they don't want to get into that. So people who do these materials may export parameters for other team members to tweak, like density, or it can be any number of parameters, so that some people don't have to go into detail. And of course, some people may only be painting masks, for example, and they don't even need to know how it works. They just know what this mask does. So I think we achieved the goal for a tool which can be used by artists, tech artists, designers. You don't really need like technological knowledge to use it. And it's also very important, something which is skipped in many tools is like communicating with source control or undo, redo, and all the things which affect your efficiency, but you don't think of them when starting implementing a tool. But also we discovered that when multiple people are working with these species, you very quickly come across a problem that there is something spawned, but you are not sure what spawned it, which species. Maybe there are multiple species with such a mesh. So we still need to add a feature where you can point on something and then jump quickly to the species or sub-biome which spawned it. Okay, that was just to remove distraction. And a little neat thing we did in paths for efficient team cooperation was to add blueprint compilation checks. So as we have this template, you click compile, and if we detect that something is off, we show a compilation warning. You can add them in the engine. And let's say you didn't set the draw distance, which is a big problem for roads when you have so many meshes. So we warn that the draw distance should be set. And if you have like a tool which checks if any blueprints have warnings, you will see it in your build machine that something is wrong with this asset. And this is very helpful because it's just impossible for a human to remember all the little things you have to set to make things right. So having reminders like that was very useful for us. And also we can configure these errors to maybe hide them or selectively disable them when it's needed. And concluding, first off, it took us, we were expecting to make these tools within 1.5 to 2 years. It took us 4.5, and there is still, of course, a lot of work left. So making good tools is a lot of work. And also another conclusion is that procedural generation was often a misconception that once you have it, you limit your control. I think it's totally untrue. It only matters how you develop your procedural tools. And I really think that proceduralness should be part of modern tools pretty much. There's no reason to be doing things manually all the time. And I think just in general in our industry there's too much of repeated and wasted work. And it's also because when our division changes and you remove work, people are frustrated, but also they are afraid of these changes. So I think it has this demotivating factor that if I do this and they then remove it, it's very frustrating. So when working with such a tools, you're not afraid of it. When you are creating a biome, it will not be wasted. You will use it, and if you need to move it elsewhere, you will just use it elsewhere, or you'll be gradually modifying it. It's not like you just throw it away. So I think this is super important for overall savings in game development. And in general, you shouldn't be afraid of change. You shouldn't be afraid of vision changes or concept changes. You should just make these changes cheap through technology. And I thought I should mention this, that these tools will be, you will be possible to buy it if you want, and Errant Biomes will have a release next week, probably. We're final stages of testing. Errant Landscape will have a beta soon, and with planned release later this year, by the end of the year. And paths will have a beta probably by the end of the year and release in spring next year. And of course, the tools I'm showing you were made by multiple people, and I can't skip Adam Wolski, who's been pouring years of his life into this. Yeah, and lots of other people who helped and contributed. So if you have any questions, go on. No questions? Okay, thank you then.